Hi everyone, my name is Pradyumn Kejriwal, and today we will be having the PCD for CF round 1032, which was Division 3, and we'll discuss the problems from A to F. Alright, but before we begin, let me tell you about our courses at TLE Eliminators. So, if you are someone who is trying to level up in CP and just stuck at only one or two problems per contest, our self paced courses are for you. We have structured the program into four levels so you can start from wherever you are: beginner, pre intermediate, intermediate, or advanced. You will learn the most relevant CP concepts through video lectures by educators, followed by carefully curated practice problems combined with guided hints and detailed video solutions that help you understand the why and not just the how. We believe in helping you build real intuition. If you need more help, you will get instant doubt support from higher ed mentors, so you are never left stuck. And beyond learning, you can enjoy leaderboards, progress tracking, internal contests, and PCDs to help you motivated and consistent. Pick the level that fits your goals and start learning today. And if you are not sure which level you should choose, then you can watch this video right here. And if you want still more information, then you can look at the syllabus for every level and also its video. So we have a video for every level. All right. And you can look at the syllabus and the prerequisites. All right. So let us begin today's PCD. So first problem was A, which was that, okay, I am audible, right? First of all, am I muted? Okay, I am not, right? But anyways, I will try to like increase the volume. So now you all might be able to hear me better. But why is it not letting me do that? Anyways, yeah. So today we had the problem A, which was you are given an array of distinct integers x1 to xn and an integer s. Initially, you are at s on the x-axis. In one step, you can perform exactly one of the following two actions: move from the position pause to pause plus 1, or move from pause to pause minus 1. A sequence of steps will be considered successful if during the entire journey you visit each position xi on the x-axis at least once. Note that initial position s is also considered visited. Your task is to determine the minimum number of steps in any successful sequence of steps. So what they are saying is that in one step, like we're on the x-axis, we are on the x-axis, and in one step we can move either right plus 1 or left minus 1. And on the number line there are many spots which are um, marked. Okay, so we have to make a journey and visit every marked spot. Okay, and we start at this position right here, right? So there might be a dot here as well, so we have to just visit all the dots. So they are asking for the minimum number of steps in this journey to complete all of the dots, right? So in this case you might be able to see that here we can just simply go left, and then we can go right up until here. So in this case we can go until this point, and then go right until this point, right? Then for example we have other test cases as well. Let's say we take this test case 1 2 3 and 10. 1 2 3 and 10, and we are at 3 initially. We are here initially. So what we can simply do is we can just go to the left till 1. So it will take 2 steps to do this, and then again we go till 10. So it will take 9 steps to do this. So total 11 steps we can do, right? So 11 is the answer to this test case. All right. But one more option that we have is that we can first go right. Okay, we can first go right from here and then we can go left. So it will take, this is 7 and this is 9. So 7 plus 9, which is 16. So since 16 is greater than 11, we will choose the answer as 11. So basically, we have two options. Like in the optimal case, we have two options that starting from S, we can either move left until the leftmost mark point and then just go to the rightmost mark point, right? One is this option, or other option is we can first go to the rightmost mark point and then we can go to the leftmost mark point from there. So whichever one is smaller, we can just print that. So we can just check both of the answers. So in this case, like, what is the answer? Let's say we move left first. Okay, so it will take absolute value, or like absolute value of s minus a0 plus a of n minus 1 minus a of 0. Right, like first if you want to go from s to a0, then so it will take s minus a0 distance and mod value, because s can be here as well, like s can be before a0 as well. So in that case also it is absolute value of s minus a0, right? So this plus a of n minus 1 minus a of 0. So that means the last point minus first point, that distance, right? This is one option. And one more option is that absolute value of s minus a of n minus 1 plus the same thing a n minus 1 minus a0, right? So we will just take the minimum of these two options. Okay, so all right, this is the logic here. So do you get it? Guys, just tell me, do you get it? You can just look at these two values and just print the minimum of them. So if you have any doubts, then just let me know. Okay, so I'll just show the code. So here we have in my solve function ns c in ns int a of n, and I'll just take the input. So this entire thing was taking the input. The actual answer is just one line. And what is that one line? It is just minimum of these two values, this value and this value. So what is this value? It is absolute value of s minus a0 plus last minus first, right? And this one is absolute value of s minus a n minus 1 plus a n minus 1 minus a0. So we'll just print the minimum. All right. Okay. So this is done. So I think we can move on to the next one. All right. So B was, you are given a string of length n consisting of lowercase letters of the Latin alphabet. Determine whether there exists three non-empty strings a, b, and c such that a, b, and c form S. Okay, and the string B is a substring of the string a plus c. Okay, all right. So what we have here is that we have a string S. We have been given a string S, and we have to partition this string S into three strings a, b, and c. Okay, such that they are non-empty, like they cannot be empty, and also their concatenation has to be equal to S. Okay, and such that this B, like this B, should be a substring of a plus c, right? So in this case, one thing that we can do, like one intuition that we can have, is that we want to like just keep b as small as we can. Like, what is the benefit of keeping b of two letters? Like, let's say I have a c c. Okay, so some of you might say that let us just break it from here. So this is string a, this is string b, and this is string c. And so here b is equal to ac. Like, b, the string b is ac, and the string a plus c is also ac. So since this is substring, this is a substring of this, you will say that it is correct, right? But why do that? Like, why can't you just um why can't you just take one letter? Like, just take one letter for b, okay, and the rest of them, like whatever is before b, just take it for a, and whatever is after b, just take it for c, right? And then if this letter comes either in this string or in this string, then it is satisfied. Like, what my strategy here is that, let's say we have a string, okay, like s0, s1, s2, up to s of n minus 1, right? Then what we can do is we can just simply take a single letter, all right? Just take a single letter as the string b, all right? So of course everything before it has to be a, and everything after it has to be c, okay? And now we want that this single letter should be a substring of a plus c, right? This single letter has to be substring of a plus c. That means that this this letter b should be there in a plus c. So that means that it has to be in either this part or this part. Or we can say that if its frequency, like if its frequency in the entire string, if it is greater than 1, like at least 1 it is, right? Because here it occurs, so it is at least 1. But if it is greater than 1, then that means it occurs one more time in either this part or this part, okay? So in that case, you can say that this s2 is a valid character for b, okay? So essentially what I'm saying is that if you can choose some character from the middle, such that on the left you have a and on the right you have c, and that character has frequency greater than 1 in this string, then you can definitely partition it like that, that b is this string and a and c are those strings, okay? So you just want a character which is like that. And definitely you cannot take the first or the last characters, because in that, like if you take this thing as b, then your a would be empty, right? A would be empty. So you cannot take the first and last characters, except that you can take anything, like you can take any of the middle characters to be your b. So let's say you take this as b, in that case this will be your a and this will be your c. And if this letter occurs anywhere else, in here or in here, that is its frequency is greater than 1, then we can say that it is correct. So what we can just simply do is we can iterate over all of these indexes which are not the first and last, okay, and just check that what is their frequency. And if their frequency is greater than 1, like any one of them is greater than 1, then you can just say that yes, we can just take that string. So the answer would be yes in that case, otherwise the answer is no, okay? So I hope it is clear. If the S1 to Sn minus 2 is related to S0 Sn minus 1, if not, then check inside. Like, okay, I'll re-explain it. Um, what I was saying is that, see, you want that whatever letter you choose, like let's say that you choose this letter for your B. So this is your substring B. Therefore, this entire thing is your A, and this thing is your C. Okay. So you want that this letter or this string, essentially, this string should be substring of A plus C, right? So that means that this letter right here should be in either A or it should be in C, right? So that means that if this letter occurs anywhere else other than this position, like either here or here, then we can say that it is valid, right? So if it occurs here, then of course there is one occurrence here. And if its frequency is greater than one, like if it occurs more than one times in this string, then definitely we can say that it occurs either in A or in C, right? That's why we can say that it is valid. And we can just say yes. All right. Okay, so I'll just show the code if it is clear to all. So we have string s, int n, and I see in n and s, and I have this frequency array for my string. Okay, so for int I equal to 0, I less than n, I plus plus, frequency of s of I minus a plus plus. All right. So now I'll just iterate over all the letters who are not the first and last. So I'll start from I equal to 1 and go till less than n minus 1, right? And I plus plus. If the frequency of current letter is greater than 1, then I'll print yes, because I can take that letter as B, right? And if all of these letters have frequency and only 1, then I'll print a no. Okay. So this is the entire logic. Okay. So is it clear to you? Anyways, hope it is clear to all. All right. So I'll move on to problem number C now. C is called those who are with us. You are given a matrix of integers n, sorry, with n rows and m columns. The cell at the intersection of ith row and jth column contains the number aij. Okay. You can perform the operation exactly once. Choose two numbers, r and c, like one row and one column, for all cells in the matrix such that I equal to r or j equal to c. Decrease a of ij by 1. You need to find the minimum possible maximum value in the matrix A after performing the exactly one such operation. So what you have here is that you have a matrix, right? And in this matrix, what you can do, like what you have to do, is that you have to choose one R and one C. That means you have to choose a row and a column. Okay. So this row, let's say, and this column, and then you will just decrease all of the elements in this row and column by 1. Okay. So you will just decrease all of the elements in this matrix, I mean in these row and columns by 1, and this element as well you will decrease by 1 only. Like even though this element is in both the row and the column, you will reduce it by 1 only, not by 2. Okay, so you will decrease all of these elements by 1, and after that you will check the maximum value in the matrix, that what is the maximum value in the matrix, and your goal is to minimize that after performing only one operation, exactly one operation. Okay, all right. So let's see a test case. Like here we have 1 2 3 2 3 2 1 3 2 1 3 2. Okay, so 1 2 3 2 3 2 1 3 and 2 1 3 2. All right, so here let's say if you just choose this column and this row, and you decrement all of the numbers, then what will it become? It will become 1 2. Okay, I'll make a line. It will become 1 2 2 2, 2 1 0 2, and 2 1 2 2. So as you can see that in this matrix the maximum value is 2. Maximum value is 2, and that's why your answer for this test case is 2. Right, fifth test case the answer is 2. Right. Okay, so that's what you have to do. And like in this case, let's say which case, uh, or okay, I'll just explain this, like samples. I think you have got the problem now, so I'll just explain it. Okay, so yeah, here in this case what we did is we chose this column and this row and just decreased the row and the column by 1. Okay, so we got this matrix which has maximum value as 2, so we printed the value 2. All right, so one thing that I want you to notice is that, let's say that the initially the maximum value is something, like in this case the initial maximum value is 3, right? 3 is the maximum value initially. Okay, and in this step that we are doing, we can do, like we can at most reduce any number by 1. Like we definitely cannot reduce a number by more than 1. Okay, so that means that whatever I do, I definitely cannot make this 3 less than 2. Like it can be at least 2. It will be at least 2, right? It will be either 3 or 2, depending upon whether or not I choose this row or column, right? So my point is that if initially the maximum value is 3, then finally it cannot be less than 2. Like the answer can be at most, like at least 2. That is, you cannot go less than 2 because you cannot decrease any element's value by more than 1, right? So you cannot really decrease this maximum value by more than 1, right? Okay, so now let us check that can you actually make the maximum value 2, or is the answer 3? So now at this point you will notice that the answer is at least like either 3 or it is 2. Like if we can decrease all of these threes, all of these threes to a 2, then definitely we can say that the answer is 2. And let's say if we cannot decrease all of these threes, like let's say whatever we do, one of the threes is remaining, then we can say that um and the answer is 3, right? So if we are able to decrease all of the threes in one operation, then the answer is 2. Okay, but how do we determine that can we decrease all of the elements to a 3 or not, I mean a 2 or not? So like basically now what you have is that here the maximum value is 3, right? So wherever you have this maximum value, you want to ensure that you are doing operation there. Like whatever R and C you choose, you have to ensure that every position has to have either that R or that C, so that its value gets decremented by 1. Okay, but now the question is, how do you actually determine that? Like how do you determine the value of R and C such that all of these are covered? Like here you can simply notice that if you take this row, and if you take this column, then all of these threes, all four of these threes have been covered, right? So you can just do that. But how do you actually like detect in code that can you choose such a cross? Like essentially you want to make a cross, right? A plus sign, if you might. So you want to make a plus sign such that every maximum value is on that plus sign. So how do you do that? Let us think about that. So actually there might be many ways, but what I did was that, okay, I have two cases, all right? Actually I have four cases, but there are mostly two cases only. Like mainly there are two cases, but I'll go over them one by one. So my first case is that the maximum value in my matrix, the maximum value occurs only once. Like let's say the maximum is 3 and it occurs only once in my matrix. All right. So in that case, what I can do is I can simply just decrease it, right? I can just decrease it. Like there is no issues in there. So in that case, the answer is maximum minus 1. Right? If I have only one occurrence of the maximum in my matrix, then the answer is maximum minus 1. This is one case. Okay. Now in second case, I have more than one occurrence. More than one occurrence of my maximum value, right? So in that case, what I can do is that, like, okay, just take any two arbitrary occurrences. Okay, like let's say one I have here and one I have here. Okay, like one maximum I have on this index and one maximum I have on this index. So as you can see that um, they have the same column. Okay, like let's say that in the first case, the two occurrences that I choose have the same column. Okay, they have same column. So in that case, what I can simply do is I can be sure, like, see, I want to choose one R and C, right? To do the operation I need to choose one R and one C, right? But if I have this case that I have two maximums, like I just chose two random maximums, okay, and they happen to be on the same column, like this, they're on the same column. So that means definitely that I'll take my C as this one. Okay. Like if you don't take this C, if you take this cell, let's say you take this C, then there is no way that you will be able to decrement both of these. Okay. Like you can do this thing, let's say. Like you can choose this row, but in that case, only this one will get decreased, but not this one. So if there are two maximums in the same column, then you have to decrease that column. Like your C will be that only. All right. And your row will be either this one or this one. Okay. So your row is either this one or this one. So what you can just simply do is you can simply check both of them. Like just check this one and, like, okay, like just check this pair of R and C. So if all of the maximums are on this pair of R and C, like if all of the maximums are on this, then you can simply answer ma minus 1. All right. So just check that. Or you can check, like, or one more possibility is that you can check this R. So this R you will check. So if all of the maximums are on this R or this C, then you will also print maximum minus 1. All right. So this was the case where the two maximums that I chose had the same column. All right. But what about the second case? Second case is they have same row. Like if they are in same row, then similar thing we can do. Like definitely our R is this, right? Our R is this, and our C can be either this one or it can be this one. So we just check both of them. And the third case is that um, our two indices, maximum indices, they don't have the same column or the same row. Okay. So in that case, what you can do is you can simply um, like you can see na that either it is like this. So either you will take this column and this row, right? Or you will take like this. Like I'll draw in red if it lets me draw in red. Um, okay. Yeah. So either you can take this white row and column, or you can take this. You can take like this. That is, you choose this row where this object lies, and you choose this column, right? And other than that, you have no options, because if you choose anything else, then either this one will not be satisfied or this will not be satisfied. So just check both of these possibilities, that are all the other maximums coming on this. All right. So I'll just dry run quickly on the test cases. So like here you had this thing, right? 1332, or okay, I'll take this test case. 1232, 1232. Then we have 3213, and then we have 2132. Okay. So what I said was, just look at all the maximums. This maximum, this maximum, this maximum, and this maximum, and just take any two of them. Okay. So let's say that we took this one and this one. Okay. So in that case, what we see here is that these two don't have a common row and a common column. So we basically know that either it is like this, like the cross is like this. Okay. So here you take this column and, sorry, not like this. We know that it is either so you take this column and this row, right? Either it is like this, okay, or it should be like this. Like what I did was, either you will take this cell's column and this cell's row. That means you will take this row and this column, right? Or you will take this cell's row and this cell's column. So like this, right? So you will check both of these. Like you will check this case as well, and you will check this case as well. So as you can see that in this case, these two threes are not on the RNC. So definitely you cannot choose this. So what you will do is you will try this one as well. So when you try this one, you notice that all of the threes are on the row or on the column. Okay. So that's why the answer will be 3 minus 1, which is 2. Right. So that was the case if you had chosen these two to analyze. Like you can choose any two. Okay. You can choose any two maximum values and just analyze using them. So for example, if I had chosen this one, let's say I have chosen these two, then they have same row, right? Okay, my bad. Okay, there is one flaw in the explanation, that here it is not necessary that you choose either this or this, right? Like if you choose this row, okay, okay, there is, my bad, guys. Just I'm sorry for that. My bad. Um, the thing I told you was wrong. Okay, so what I told you here was, if they are in same row, then the row has to be this one, and the column can be this on this, either this or this. But that is wrong, because it can be this one as well, right? If this is the case, then they can be this one as well. So actually the logic is that we can just determine that this is the row. Okay, just hear me out, guys. This is the correct logic which I submitted actually. So what I actually did was that, if you see that if you take these two cells, right? If you take these two cells, you can see that they are in same row, right? They are in same row. So definitely you will know that you will take this row, right? And for column, you can take anything else. I mean, these two don't care. You can take anything. So what you can do is you can just iterate over the list of vertices. I mean, you will just check all of the vertices. Like first you will check this, okay? So it is in this row, it is fine. Then you will check this. So it is in this row, it is fine, right? Then you will check this. So it is not in this row, right? It is not in this row. So you have to make it in a column. So therefore, you will make this column, right? And now you will check this one. So you will see that it is in this column. Okay. So my bad, guys. I uh, thought something else which was wrong. So my point here is that first case is that there's only one occurrence of max. So in that case, the answer is just ma minus one, right? Second case is that there are more than one occurrence. So what you will do is you will just take any two occurrences. Okay, you will just take any two occurrences, and if they are in same column, let's say, if they are in same column, then you are sure that this is the column that you will take. All right. But what about the row? So for the row, what you will do is when you're checking, right? Like when you're checking, you will check this one, so it is on the column, so it is correct. You will check this one, it is on the column, it is correct. This one on the column, correct. But then this one, you will check this maximum value isn't on this column, right? So definitely, if you want to minimize it or decrement it, you need to give it its row. So now your row is this one. Okay. So this is done. Now you will check ahead. This one also is done, and this one also is done. And that's the algorithm here. Like since you can be sure that your column is this one only, you can just arbitrarily apply this column, right? And whatever vertices are there, not on not on this column, you will just check that they are in same row, essentially, right? And for the same thing for the row, right? And this was correct. This was correct that if your two cells are on different row and different column, then definitely you will have uh, either you will have like this, that this column and this row, or you will take like this, that this row and this column. So you will check just both of them, just check both of them, and if anyone is correct, then you are fine. So just to explain once more clearly, I will take this test case as well. 1332 2322. 1221 3323. All right. So here maximum value is 3. So this, and this. So let's say you take these two maximums. Okay. You take these two maximums, these two. So they are in same row, right? They are in same row, definitely. So the row is this one. Okay. So now you will iterate over all the positions. So okay, this one is correct because it's in this row. Then this one is correct, it is in this row. Then you see this one. So since it is not in this row, you will have to draw this column. Okay. So you will draw this column. Now you check this one, it is in this column, so it is fine. Now you check this row. Now, so since this one is not in this row also and this column also, so you will know that okay, it is not possible for this case. Like definitely it is not possible. So the answer is no for this case. Okay. So I hope you all understood. Like just disregard my previous logic that one of the column is this only. So that was wrong, but this is correct. Okay. So sorry for the like confusion, but do you get it, guys? That just take up any two of the vertices which have the maximum. All right. And then you have three cases that either they're in same row, or they're in same column, or they are completely differently. and all three cases I told you. Complexity I'll discuss. I'll show the code and I'll discuss. One more time explanation. So okay, I'll just give a summary. So here, one thing that I told you is that, see, the maximum, like let's say here this is the matrix. All right, this was your matrix, right? So the maximum value was 3. Okay, it was here, 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 and here. And since you can only decrement any element by 1, so therefore the maximum cannot be less than 2. Like at most what you can do is just decrease it to 2. Like you cannot decrease it even less than 2, right? And to make it 2, that would mean that you would have to decrease all of the elements which are 3 to 2. That means your operation should be done on every index which is 3. So this one, this one, this one, and this one. So for that, like you can clearly see here that you can simply choose this column and this row right here. So all of these four indices have been affected by this, right? So just determine that can you do this or not. So to determine that, I have made two cases. One case is that we have only one 3, like only a single value is the maximum value. Okay, so in that case obviously the answer is possible, like we can definitely decrease that value by just selecting that row or that column, whatever. So the answer is maximum minus 1. Now if there are more than one occurrence of the maximum, then we can select any two of them, like just select arbitrarily any two occurrences. Okay, so just select any two occurrences of the maximums. Okay, so now if those two occurrences have the same column, okay, then in that case definitely your column would be this one only. Like it is not isn't possible, it isn't possible that you take some other column, because in that case you can't do both of them. So if you have two occurrences which have these same column, then definitely you will take this column only. Now, right, now what you will do to check for the row, like how do you get the row now? So what you can do is just iterate over all the different positions of balls, I mean of the maximum values. So let's say you check this one, it is on the column, so it is fine, it will be decremented. Then this one you will check, it is fine, this one's also fine. Then you will check this one, so this one was not on the column, like this one is not on the column. So but we want to decrease it, right? We want to decrease it, so we'll have to give it the row. So we will take this row. So now the row is fixed, so it is done. And now you will check these ones as well, right? So if all of them are on the same row, then it is fine. And similarly, if you can do that, if the two that you chose were on same row, then you will just fix that row, and the column will be variable, like anything can taken as the column. And if both of them are not on the same column and same row, like if the two occurrences that you chose are not on the same column and same row, then definitely you can either do this thing, that take this column and this row, okay, or you can do that, take this column and this row, right? You have only two options, so you can select either one of them and it will work. Okay, yeah, it is n into m, I will explain that. So guys, do you get it, or do you still have confusion in some part? If you have some confusion, then you can ask me, like in some part if you have confusion, then just ask me. And like if you did not get the entire thing, that you can, then you can ask, like sorry, then you can just rewind the previous one. Yeah, I'll show the implementation. Okay, for Lakshya it is clear. Lakshay, sorry. Hmm. So others are not asking any doubts. So I'll show the implementation now. My idea is just to take any two arbitrarily, like any two arbitrary maximum values, and just check them. Okay. So here I have a check function. Check function basically takes this. Okay, I'll come to it anyways. Int nm scene nm, int a of nm. Like I'm taking the input. So here is the I'm taking the input, and also I am taking the maximum value. So ma is equal to max of ma comma a of ij. So this is the maximum value. All right. Then I have this vector of pair which stores all of the indices of the maximum value. Like this vector will store all the positions of the maximum value. So I'll just iterate over the entire matrix, and if a of ij is equal to maximum value, I'll push back I comma j. Okay. So now if the size is 1, that means the maximum value only occurs once, right? Then I'll just print ma minus 1 and return. Okay. So now if it is not false, like if it is not true, that means I have at least two occurrences, right? So I'll just take the first two. Like I'll just take v of 0 and v of 1. Okay. So now if their first, like if their x coordinate is equal, if v0 dot first equal to v1 dot first, that means they have same row. So now my r will definitely be equal to v0 dot first, right? And my column is yet undecided, like it can be anything. Okay. So what we can do is we can iterate over all of the indices of the maximum value. Okay. So for int I equal to 0, I less than v dot size I plus plus. If v of I dot first is not equal to r, like see the current vertex that I'm at, that I'm at, if it is not on this row, the row which I chose, then I will make the column into that row. Like I'll make the column to that vertex. Like what I'm doing here is if I have these two cells on the same row, okay, and then I have this cell right here. So what I did was I just chose these two, right? And then I chose this row because they're on same row. Then I iterated. So I checked this one, I checked this one, then I checked this one. So I saw that its x coordinate was not equal to this r, like, right? So therefore I have to give this column, like, so the c is equal to v of I dot second, like its y coordinate, right? So I set my c to v of I dot second, and there is only if c equal to minus 1. Like if till now I have not assigned any column, then I'll assign it, right? And if I've already assigned it, if I already assigned this column, then it has to be equal to v of I dot second. Like that column, if I already assigned, like let's say I have this and this, then I check for this one, it is not on this row, so I assign this column, right? Then we have this one, okay. So we check for this, it is not on this row, right? And also we have assigned this column, like we know that this is our column, and since this is not on that column, we will just say that it is not possible, right? So flag equals to false. Like if c is not equal to y coordinate of vi, then flag equals to false and then break. Or we could simply print ma here and then break. All right. And finally, if flag, then that means every vertex in this loop is there on um, our row and column. So I'll see out ma minus 1, right? Now the same thing for the column. Like if the y coordinate of the first two is same, then definitely the column is that y coordinate and row is undecided yet. Then flag is true initially. Then I iterate over all of the vertices. If that current thing is not equal to my column, like If the y coordinate is not equal to column, then row has to be equal, right? So if the row is undecided yet, if the row is -1, then I'll just assign the row to this column. I mean, to this cell and continue. Otherwise, if row is assigned already, and if it is not equal to, we have find out first, then I can just print minus, like I can just print ma and break, like and return, right? Like I will know that I cannot possibly do it. So I'll see out ma and break. All right. And finally, if flag, that means if this was not the case anywhere, so I'll just print ma minus 1, right? So this was the case for the same row, and this was for the same column. And finally, I'll just, like, if I have, I mean, if both of them are false, like if both of them are not true, then I'll just check for this thing. Like, I'll just check that if I take um, x coordinate of the v0 as my row and y coordinate of the second v of 1 as my c, then I'll check that is it true. Like I'll check function right here, which takes in all of the indices at which I have the maximum element and the row and the column, right? And it just iterates over the entire thing. It iterates over the entire vector, and if it is not in the row and not in the column, then return false. That means if we take this RNC, then we cannot decrement all of the indices in this vertex, in this vector, right? So return false, and otherwise return true, right? So in the end, like what I have here is I am checking this v with r equal to x coordinate of the first one and c as this v1 dot second, or I'll check with v of 1 dot first and v of 0 dot second. Like I told you right here, that if I have these two maximum values with different row and column, then either I will take this row and this column, or I will take this column and this row. So I'll just check both of them, that is it satisfied or not. And if it is satisfied, like if it is true for any one of them, so I have put in or in here. So I'll print ma minus 1. All right, and return. And like until here, if we haven't printed ma minus 1, that means we'll just print ma. It is not possible to get this condition. And the TC of this is just O of n into m, because as you can see, like this loop here is worst case O of n into m. It is just v dot size, right? And so both of these cases are just O of n into m. And this case as well, like this check function will take at max O of n into m time, right? So the final TC is just O of n into m. Yeah, like two arbitrary points I just chose, and if they're on same, like if they're not on same column and same row, I am just trying both the cases. Yeah, that is true. Quick recap. So, okay, what I so till here I think it is clear that we have to like decrement every instance of the maximum value. So wherever there is the maximum value, we have to decrement it. So let's say if we have 5 maximum values in our matrix, so we can just choose this column and this row, right? But how do we find it out? What we can simply do is we can arbitrarily pick any 2 points, like let's say this point and this point, okay? And so if they are like if they have different row and column, like they are not in the same row and not in the same column as well, right? So definitely you can say that either you will take this row and this column, or you will take this row and this column, right? So you would check for both of them. So you would just check for both of these numbers, I mean both of these configurations, that are all of these uh, possible, like are all of these points coming on these row and column or not. So as you can see that if I try this thing, then they are coming, right? And like if you choose any like such two points which are on the same row, then that means your row would be this only. Okay. And then you can just check all of the vertices that are they on this row. So this is on this row, this is on this row, this one is on this row, but then this one is not on this row, right? That means you would have to give it the column. So you will take this column, and then you will just check that okay, it is right, and this one also it is in this column, so you will just tick it, right? But while checking, let's say you have something like this, like let's say you have something like this. Okay, so in this case, let's say you chose these two and first, so you will take this row, right? Then you will take this, you will take this, you will take this, then you will go here, and you will make this row, make this column, I mean, because this one is not on this row, right? So you will choose this column and take this, then you will take this, but then you will come here and you will see that your column is this and your row is this, but this one is here, so you cannot take it, and therefore you cannot decrease it, and therefore the answer is just maximum value. All right. If I count the maximum elements in each row and column, then if I find that there are more than one rows and columns with more than one element, then the answer is m, otherwise it is m minus 1. Okay, I'll just answer these doubts later. Like first, I'll think about this. Mm, at every row where there is at least one occurrence of maximum element, we take count of every cell there. Okay, sorry. If I count the maximum elements in each row and column, and then if I find that there are more than one row and columns with more than one element, no, it is not correct. This is not correct because you might have this, right? Like, let's say these three are your maximum elements. Then in that case, you will have no such row which will have more than one maximum element, right? But in this case, you cannot make a cross. So in this case, your algorithm will give the answer maximum minus 1, and my like correct answer is maximum. All right. Okay, Madhav. Then someone said, firstly, I find the coordinates of maximum number and I iterated every column for every row, which is O of n square. So it is O of like nm square actually. Like what you are doing is you are fixing this r and c. Like you are checking for all r and for all c. So that is n into m. And to check also you are taking like number of maximums, number of maximum times, number of maximum occurrences, right? And that can be up to n into m, right? So this is O of n square m square. Okay. Like I don't think 139 ms to TLE would happen unless they get some test case where your complexity is very high. Like most probably it won't happen. What if we just fix the two rows and columns and check all of the maximum elements lie in either that row or column? Yeah, that's why I told you that we cannot do that because if you want to fix this row and column, that will take n into m ka loop, right? And to check also, you will take number of maximum occurrences time. Like you will take the time to check is proportional to the number of maximum occurrences, like the number of times the maximum occurs, right? And that will give you TLE, because the maximum can occur n into m times as well. So that will be O of n square into m square. Can we take a row array and a column array and increase the frequency of max element in their respective row and column array by 1? Then the row maximum frequency and column maximum frequency can be chosen. Um, but if you have multiple maximums, then like let's say you have this test case. Okay, so in this case, this row has 1, this row has 1, this column has 1, this column has 1. So let's say you choose this row, the maximum row, and this column. So in this case, you will just say that MA is the answer. But this is the answer, right? Like the answer is MA minus 1. Last condition while taking row of one and column of the other is not required, as it is covered in the first and second test case. No, I in the first and second test case, I am only checking if they have the same column or same row. Like if you can see here, in my first case, I am checking if the x coordinate of v of 0 and v of 1 is same, and then only I am doing this, right? And if their y coordinate is same, then only I am doing this. Sorry. But what if they are both not same? They are both different. Then what will you do? So in that case, I'll have to do this thing. Let's say R1, R2, C1, C2 are rows, comma, column of first two elements. Check whether all the maximum elements coordinates are either equal to R1, C2 or R2, C1. If not, answer is max. No, that is wrong. Because let's say you have this, and this. Let's say this is your 1, this is your 2. Okay. So you have R1 and C1 and R2 and C2, right? But in this case, in the actual answer, the column is not C1 or C2, it is C3. That's why it is wrong. Okay, Kavish. Okay, so wait a minute. What do you want, Cosmic Boy? Manish wants me to discuss D. Okay, yeah, let's move on. We have spent too much time on this problem now. All right, 1709. You are given two arrays of integers a1 to an and b1 to bn. It is guaranteed that each integer from 1 to 2n appears exactly once in the arrays. You need to perform a certain number of operations so that both of the conditions are satisfied. For each I from 1 to n minus 1, ai should be less than a of I plus 1 and bi less than b of I plus 1. And for each I from 1 to n, it should hold that ai is less than bi. In one operation, what you can do is swap ai and ai plus 1, swap bi and bi plus 1, or you can swap ai and bi. So no need to minimize both the operations, but They have to be less than equal to 1709. Find any sequence of operations that satisfy both the conditions. Okay. So yeah, here basically what we have is we have two arrays of same length. Okay. So let's say n is equal to 5 right here. So we have the numbers 1 to 10. 1 to 10 written in these blanks, and each number comes only once. So every number comes and they come exactly once. Okay. And what we can do in one operation is we can either swap these two indices, I mean any two side by side, or we can swap up and down. All right. So we can do that side by side or up and down. And then what we can do, like we have to ensure that your a of I is less than a of I plus 1, b of I is less than b of I plus 1, and your a of I is less than b of I. Okay. For all indices I. So you want to ensure this. And you can swap any vertical or horizontal. All right. So how do you print this? So guys, any ideas here? Like, is it similar to, okay, first of all, n is up to 40 only, right? N is still 40 only, and we can do up to this one operations, 1709 operations. So in that case, like approximately n square, right? Approximately n square operations are allowed, right? So what can you do? Brute force. Brute force how? Like, can you just give one term? Like there is one very nice approach of this. Sort A and then B, and then swap for where AI is greater than BI. I think that will not work. Bubble sort, yes, correct. But this will not work. Like, I don't think it will work. Like, let's see. What you are saying is just sort A, sort B, and then swap those indices which are having AI greater than BI. So I think I can find a test case which is not like this. So let's say I have one here, four here, and five and three. Okay, yeah, got it. So uh, wait, or what I can do is, see, I want two as well, na? Where do I keep two? If I change this three to two, and if I change this five to a four, okay, but no, this, it is not sorted. Wait, did it pass? Like, uh, Abhinav, did this pass? That you sort A, then sort B, and then just swap where AJ is greater than BJ. Okay, this passed, but I don't have the proof of this. So it might be correct, but I can't prove it right now. And what I did was something else. Okay, so what I did was that I tried to make everything, like whatever I have. So whatever is my starting position, I tried to make everything like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I try to make it like this. Okay. So as you can see, this final state satisfies all the conditions, right? AI is less than AI plus 1, and also AI is less than BI. Okay. So I tried to make this from anything that was given in the input. But what was given in the input? Like, how do I actually make this? Now that's the main question right here. So what I did was, okay, first I put 1 to its position. Then I put 2 to its position. Then I put 3 to its position. Then 4 to its position, and so on. Like kind of bubble sorting. Okay. Like what we have in bubble sorting is, let's say, 3, 4, 1, 2, 5. Right. So there, what we do is first we try to bubble this 1 to the starting. Right. So we will swap these two. Then we'll swap these two. Right. So 1 becomes here, 1 comes here. Then we try to make 2 come here, and so on. So that idea I just applied right here as well. Like what I did was, I tried to make this thing, and to make that, first I tried to make, like, I tried to bring 1 here, then 2 here, then 3 here, then 4 here, and so on. And how to do that? Like, how to do that? So for that, what I did was, I started, let's say, I have this 5 indices, right? Let's say 1 was initially right here. Okay. So first what I did was, if this 1 is not in the correct row, like, it is not in the correct row, right? I wanted it in the above row, but it is in the below row. So what I did, I just swapped these two. Okay. So I just swapped these two. So 1 came here. All right. And then what I did, I just bubbled this like this. So I just swapped these two, then swapped these two, and then swapped these two. So 1 came right here. All right. So 1 is right here. Then whatever, wherever there is 2. So let's say 2 is right here. So in that case, I'll swap these two. So 2 will come below, and then I'll bubble it to the front. So 2 will come here, right? Okay. Then and so on I'll do. Like 3 is right here, then I'll swap these two. And this works. Like, why does it work? It works because whatever elements I have already placed right here, like here I have placed 1 and 2. So this works because I am never touching these elements in the future again. Like, let's say I want to put 3 right here, right? I want to put 3 here, but initially it is here. Then this 1 and 2 will never get touched, right? They will always be in their correct position, because this 3 just wants to go till here, right? That's why I am first filling in 1, then 2, then 3, and so on. And like, even when I am doing this swap, the above swap, then also it will not affect this 1 and 2. Like, if I have 3 right here and I want to bring it somewhere else, then definitely this one is also not correct. So I can swap it with no worries. Okay. Like, you might think that, okay, here it is 3 and I want to bring 3 here. So I'll swap this with this. But what if the thing which was here is already, like, I have placed it there. It's already correct. But that is not possible. Why it is not possible? Because for that to happen, it should be like, we have 3 here and 4 here, right? I mean, you can see it is not possible. I mean, how do I explain this? You can see that it is not possible. Then in my algorithm, we are swapping something which is already put there. Like, if I have already put 1 here and 2 here, then while doing like this, going like this, I am never touching 1 and 2 again, right? So I put 3 right here. Then let's say I have 4 here. So I just do like this. Then let's say, so you get the idea. So this entire, like, this is this implementation now. Yeah, sort the first array, then sort second array, and then swap A and B. Yeah, like someone said that this also works, but I don't know why it works. So I can't really comment on that. Can you also make 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10? Yeah, I think that also works. because yeah, it will work. That also works. But I think there's only two solution. May have A have 1 to n and B have n plus 1 to 2n. Sorry, Raghav, I can't do that for the other viewers. You can just see the recording tomorrow, right? Like this live stream will be there on the channel, so you can just see at that point. You can just see tomorrow. Yeah, that's what I just did. That A will have all the odd elements and B will have even and sorted, right? And this will take like n square. I think it will take less than n square number of steps. And why is that? Because it got accepted. I mean, I did not think of that why it is correct. But let us think of that. So here, in the worst case, if you want to put one, like if you want to place one right here, then what's the number of moves? It is at max n, right? Like one move here and n minus one moves right here. Then if you want to place two, then also it will take n moves, right? Then if you want to place three, in the worst case it is n minus one moves. Okay. Then for four also it is n minus one moves. So and so on it will go on till one, right? So this is just n into n plus one. Okay. So this will pass like 40 and it's still 40, right? So 40 into 41 it will pass because this number is like um I think 1640, right? And since we could do until 1709, it will pass. Yes, we can do that as well. Soham, that is correct. Yeah, implementation. Yeah, it this one also is apparently correct, but I don't know why it is correct. So I am not telling you that. If someone can prove why it is correct, then you can comment. But anyways, I'll just show the implementation now. So yeah, I have this swap function. Okay, so in my implementation, what I'm just doing is that I have this array. Like I am just storing the current state of my both two arrays, and also I have the pos array. Like I'm just storing the position of every element currently. Okay, in a vector of pair of int comma int. So this vector of pair is of length 2n, where pos of I stores the x and y coordinates of my like position. All right. So I have just maintained these two arrays. Okay, so I'll just take the initially, and yeah, I am just storing all the operations that I am doing in this vector of pair. Like I have two pairs right here in this vector. Like what I am swapping basically. Like if I'm swapping x1 y1 x2 y2, so I'm just pushing that in this vector, right? So int n c in n ops dot clear. Okay, and this array I'll just make it the correct size, and pos also I'll make it correct size. Then I'll make it like for int for j equal to 0 and 1, and for I from 1 to n I'll see in arr of j comma I, and I'll just make the pos array as well. So pos of arr ij is equal to make pair ij, and I'm doing minus 1 here because I am having 0 indexing, right? And then what I'm doing here is that for int I equal to 0, I less than 2 and I plus plus. So in this loop, what I'm doing is I'm placing the I, like, or I plus 1 basically. So in the ith iteration, I am placing ith one in its correct spot. So basically, if I have like if I have zero indexing, if I have zero indexing, so it is like this: 0, 1, 2, 3, 4, 5, right? So X coordinate can be either 0 or 1, and Y coordinate can be 0, 1, 2, 3 up to n, right? So for the I, like for some number I, its X coordinate is just I mod 2, right? As you can see right here. And its Y coordinate is just the floor of I by 2, as you can see right here. So that's what I used here. So if cur dot first, like cur is the current position of I, right? So if cur dot first is not equal to I mod 2, that means it is not in the correct position. So I'll have to swap. So I'll swap cur dot first and cur dot second. So current position with 1 minus cur dot first and cur dot second. And then I'll update the current position. So cur dot first equals to 1 minus cur dot first. So I'll update it. And while cur dot second is greater than I by 2, so while the Y coordinate is not correct, I'll just swap it to the previous one. So I'll just swap cur dot first, cur dot second with cur dot first, cur dot second minus 1. And I'll update my cur variable because I have like swapped it, right? And finally, I'm just printing the operations. Okay. So I just print the operations right here. And you can see that in my swap function, I am doing many things. Like I am swapping also, one thing. Second thing, I am just pushing this operation into my ops array. Like this operation right here, I am pushing it back into my ops array. And also I am like whatever swap I did, I'm also updating the position of the new elements right here. So since I swapped A, B, and C, D, the elements at the position A and B, like comma B and C comma D, are changed. So I'll update them. The pos of ARR AB is equal to AB, and pos of ARR CD equal to CD. So this swap function does these three things for me here. And finally, I'll just print the operations. E digit DP. Yeah, and like you don't even need DP. Even if you just don't memorize it, it is fine. It is correct because we are ensuring that for every AI, there is a greater element in array B. Um, yes, focused, it is correct, but I did not know why it is correct, so I did not tell you that. But apparently, it is accepted, so it is correct. So it is correct because for every AI, there is a greater element in array B. Okay, well, you might be right. Can't really comment right now. But okay, I think you all got this approach that first you will, like, I am just making it like this 1, 2, 3, 4, 5, 6, and so on, right? And wherever one is, I will first transfer it to here using swaps. And yeah, I'll do that. Anyways, so I'll move on to problem E now. Okay, so problem E was this one. For two integers a and b, we define f of ab as the number of positions in the numbers where their digits are same. Like f of 1 2 and f of 2 1 is 0, and f of 3 1 and f of 3 7 is 1, because I have this 3 common at the tens place, and f of 19891 and 18981 is 2, because I have these two ones common, right? And f of 54321 and f of 24361 is 3. So you can see that this 4 3 and this 1 are common, right? You are given two integers L and R of same length in the decimal representation. Consider all the integers x between L to R. Your task is to find the minimum value of flx plus fxr. Okay, so what we have here is we have been given two numbers L and R having same length. Okay, L and R having same length, and we can take any number between L to R. Let's say X. We can take any number X between L to R, and we can simply like find out the value of f L comma X plus f of X comma R, and we have to minimize this value. Okay, we have to minimize this value. All right. So let us just look at some test cases. Let us particularly look at this test case right here. Um, okay, they haven't given any test case like that, so I'll just take one myself. So let us say we have 4,999 and 6,000. So guys, let's say you have this thing. Then what is the answer? 4,999 and 6,000. Just let me know, guys. What is the answer? Zero. Why zero? Because we can simply choose, like, for the first digit, I can choose 5, right? So it will be like, okay, now that I have choose 5 here, whatever I choose for the three indices right here, it will definitely be between L to R. Okay, like whatever I choose for these three numbers, this number will definitely be between these two numbers, right? So if I choose 5 here, I can choose any three numbers right here. So I can choose any three numbers which are not these two numbers, right? So which are not 0 or 9, I can choose. So I'll choose 1, 2, 3 or something, right? So in this case, the answer is 0, right? Previous taken elements, no, the entire L and R is this only. Like this is your L value and this is your R value. Okay. So in that case, the answer is 0 because we can just take 5. So basically, you have an insight from here. Like you get an insight from this thing that if you have a digit, or okay, let's take one more example. I'll take one more example. Like let's say we have 3344570099, or let's say 12, let's say 3412. Okay, guys. So this is your test case. Now tell me what is the answer. Two. I think you have the right track, but not the wrong, not the correct answer. The answer is 4 because you have been asked the value of fxl plus fxr. So 2 plus 2 is 4. Okay, guys, not 2. So how do you get 4? Basically, what you can simply observe here is C. Since this is your L, right, and this is your R, so you want a value between these. So if you want a value between 3 and 3, it is 3 only. Like there has to be a 3 only here. Then of course there has to be a 4 here, right? Then now, wait, yeah, now here, what you can simply do is you can place a 6 here, right? And then you can just, like, since you have placed a 6 here, now you know that whatever you place here will definitely be in between these two numbers. So you can simply place anything that you want. So on this digit you can just place any digit which is not 3 and 1. So let's say you place 5, and here you place anything which is not 4 and 2, so you place 5. So this is the number for which you get the value as 4, right? So from this insight, you can simply observe that you have two things. Okay, the first thing is that you have this, if you have same digit, like let's say you are moving from left to right. Okay, and if you have same digit, then you have to place that digit right here. Okay, you have no other option, right? So you can just place that digit and just solve for this new problem right here, right? And just add 2. Like, see, what I'm saying is, if you have these two numbers, right, then you definitely know that on the first digit you have to place 3, right? So you'll place 3 right here, and then you can just solve for this test case. Like, just assuming that if this was your L and this was your R, then what's the answer? So that answer is 2, right? And then you will just add the penalty because of this digit 3. So this 1 and this 2 penalty you will get. So you will just add 2 right here. So basically, if your L and R have the same starting digit, then basically your answer will be just, like, let's say your L is L0, L1 up to Ln minus 1, and your R is R0, R1 up to R of n minus 1. And if you know that L0 equal to R0, okay, then of course in your answer you'll have to place L0 or R0, whatever, they are same, right? So that will give you 2 penalty. So what will you do for the rest of the string? Like, you will just say that your final answer is the answer for L1 to Ln minus 1, L1, L2 up to Ln minus 1, and R1, R2 up to R of n minus 1. So that's what you can find, and just add 2 to it, right? So recursively we can say that if these L2R have same starting digit, then you can definitely be sure that, okay, you have to do this, right? But what if they don't? Like, what if the first digit of L is 4 and R it is 6? Okay, so in that case your answer is just 0. Your answer is 0. Why? Because you can simply place a 5 in your answer. Like, simply just place a 5 in your answer, and everything else you can just place as you wish. So you can just place any digit here which is not one of these digits, right? And you will get the 0 answer. Okay, so you have seen that these two cases, that what if your L not equal to R not? So in that case it will be, like, your answer will be 2 plus answer of L1 to Ln minus 1 and R1 to Rn minus 1. And if your L naught is, like, if your R0, if your R0 is greater than L0 plus 1, then our answer is 0. So right, so basically if the difference is 0, then the answer is 2 plus the recursive function, and if the difference is greater than or equal to 2, then the answer is 0. But what if the difference is 1? Like, what if in your L you have 5 here and something something something, and in your R you have 6 here and something something something, like that. Okay, so now what will you do? Now what will, sorry, you do? So now basically you have two options. Like, on the first digit you can either place 5 or you can place a 6, right? Okay, so now you can simply try both options. Like, you can try putting 5, you can try putting 6, and then recursively you will try calling the function for these numbers, right? But there is one caveat here. Like what is the caveat here? The caveat here is that I'll take an example. Okay, let's say I have 5 1 2 3 4 and 6 5 1 7 8. Okay, so in this case, let's say you take 5 for your answer. Okay, for the first digit, right? Then the point is that for second digit, for second digit, you don't have any upper limit. Like this R thing has no meaning now. Like for second digit, this R thing has no sense now, because if you have a 5 right here, then you are guaranteed that whatever you place in these four digits, it will be less than the R only, right? So you can simply disregard this digit of R. Okay, and just assume that the maximum digit that you can get is 9. Like there is no upper limit to your second digit, but there is a lower limit. The lower limit is 1. Because you put 5 here, the lower limit is 1, but there is no limit on this upper limit, right? That's my point. So what you can simply do is, in your function, like in your recursive function, you can keep two variables. Like, see, what we can say here is that this number, it is currently tied from the left. Like there's this phrase that we use in digitdp, that this number is tight, like it is tight from the left. And why is it so? Because we have put 5 here, so we need to put at least 1 here, right? So it is tight from the left. And if we put 5 here, like if since we put 5 here, we don't care about the upper limit. Like we can go as large as we want, right? So it is not tight it is not tight from the left, it is not tight from the right. Okay, so you can simply um, just pass in these variables into your answer function, and it will determine that how you can do it. So essentially what you can do at every step is, like, just define an ans variable, I mean ans function, which takes in one index. Index means that for which index you want to solve it. Like basically, you will call it for ans 0. Okay, and this ans 0 will call for ans 1 recursively. So this ans index means the answer for, like if I call it for this index, then this will return me the answer for these many numbers. All right, so basically the main idea here is that you can pass in the variables is tight left and is tight right. Okay, and according to that, you can simply figure out that what are your bounds for this digit. Okay, and if the bounds are more than one apart, then you can simply pick the middle number and the answer will be 0. Okay, so I think I am not quite clear here, so I will show some examples. Okay, so let's say I have 6 and 7, then I have let's say I have a 5 and let's say an 8, then let's say I have 0 and I have 3. So let's say my L is this and my R is this, right? So now for the first digit, for example, if I put 6, okay, like if I assume that I have 6 right here on the first digit, then when I come here, when I come here, I have no upper limit. Like my upper limit for this digit is 9. Like since I have already placed 6 here, then I'm sure that is tied from like is not tied from right. not tight from right. Correct. So my upper limit for this digit is 9. Okay. And my lower limit is 5, right? So I can place any digit from 5 to 9 here. And now since you saw that if you have a large enough gap, like if your gap is more than 1, right, then you can simply say that the answer is 0. Like we can simply place anything between 5 to 9 here. Like we can simply place anything between 5 to 9, that is 6, 7 or 8. Okay. And if we do that, let's say we place 6 right here, then we can be sure that the answer is 0 for this. And so it will return the answer 0, and this one will increment the answer, so plus 1. Like this 6 and 6 are colliding. So if we place 6 here, the answer is 1. Okay. And if we place 7 here, then what? Like we could place 7 here as well. So if we place a 7 here, okay, then for this digit, um, there is no lower limit. The lower limit is 0, because we are sure that since we have 7 here, this number will be definitely more than this L. So we don't have any lower limit, but we have an upper limit. The upper limit is 8. Okay. And since this gap is very large, we can simply put any number between these two numbers. That is, from 1 to 7, we can put anything here, and the answer will be 0. Right. So that's how you can just implement your recursive answer function, which will give you the answer for a suffix. Okay. Like I think I should be pretty clear now, or I'll just show the code for you guys to understand more nicely. Okay. What about this case? 598, 622. 598 and 622. So in this case as well, you will first, on the first digit, you have two options like 5 and 6, right? So you will try both. So first, if you try 5, then for this digit, you have the lower limit as 9 and the upper limit as 9, right? So you will have to place a 9 here, right? So you'll place a 9 here and then recursively call the function for this one. Okay. And for the variables, you will pass the same. Like at this digit, um, it was not tight on the left. Like tight left, sorry, tight left was true. Tight left is true, but tight right is false, right? So you'll pass the same thing. Like you will pass the same thing to this digit, that it is tight from the left. It is tight from the left, but it is not tight from the right. Tight right is equal to false. Okay. And similarly, so here you can see that since tight left is true, so that means you will get this 8. So this lower limit is equal to 8, and the upper limit is 9, because it is not tight on the right. So either 8 or 9, you can choose any one of them. So 8 or 9. So if you choose 9, then you get 0 penalty, and if you choose 8, then you get 1 penalty. So you will choose 9, right? So the answer for this suffix is 1. So you will return 1. Then since you put 9 here, so the answer for this entire suffix will be 2, because these two 9s are same, right? So the answer for this suffix is 2. And if you put 5 here, the answer for this is 2, and therefore the total answer is 3. Like if you put 5 here, then the answer is 3. And if you put 6, then what? 598, 622. So if you put 6, okay, then in this case, the upper limit is 2 and the lower limit is 0, right? So you can simply put 1 and the answer is 0, right? So the answer for this suffix is 0. And so your answer for the entire string would be 1, because this 6 is matching with this 6. So in the worst case, basically you have two choices. Like in the worst case, you can have two choices at every position. Like let's say at each position, um, you have like a gap of 1, like between the lower limit and the upper limit, you have a gap of 1. So you would have two choices at every position, right? So at max, like the in the worst case also, the time complexity would be 2 to the power 9. Like since you need to explore both paths in this tree, right? Like let's say at the digit 0, your gap is 1. So you will explore both the lower limit and the upper limit, right? And then let's say here also, your here also your gap is 1. Then you will again explore both lower limit and upper limit. So this will make a tree, right? This will make a tree which has depth equal to number of digits, right? And since the number of digits is equal to 9, only 9, so we can say that this tree's size is 2 to the power 9, right? And therefore in the worst case also, my algorithm runs in 2 to the power 9 operations, so which is only just 512, 512, and here t is given to be 10 to the power 4. So total you have 512 into 10 to the power 4. Okay. Focused. Yeah. I started checking prefix and stored both integers until the difference between them becomes greater than 1. Yeah, that is correct. All right, so let us look at the code now. So what I did was C in LR and print the answer of 0 comma true comma true. What is true comma true? It is just that is tied. Like is tied from left, it is true, and is tied from right, it is true, and the index. And my recursive function answer, what it will do? First of all, the base case, if index is L dot size, that is I am like I have just traversed the entire string, then return 0, right? Now low and high, that means lower limit and upper limit. So by default, the lower limit is L of idx and the upper limit is R of idx. But if it is not tied from the left, then the lower limit is 0. And if it is not tied from the right one, if it is not tied from the right, then the high is equal to 9. Okay. Now if the gap is too large, like if the gap between high and low is more than 1, then we can say that the answer is 0, right? And if high equals to low, then definitely we will choose for this digit. For this digit, we'll choose this value only, right? So I'll return this ans of idx plus 1 comma title plus whatever are equal. Like I just chose high for this one, right? So if L of idx is equal to high, then I'll add 1 to my answer, to my penalty essentially, right? And if this is equal to, this is true, then also I'll add 1. Okay. And otherwise, this means high equals to low plus 1. So either we'll choose high or we'll choose low. All right. So either we'll choose high. So okay, here we choose low. So if we choose low, then it is ans of idx plus 1. Then title remains title, but tit r becomes false, because since you chose low and you had the option till high, so that means that from the right side is not tied anymore, right? So it is false. And plus L of index equal to low plus R of index equal to low. That means since I chose low for this digit, if L or R is low at this digit, I'll just add that, right? And also one more option is that I choose high. So answer of idx plus 1 comma false, like from left, or from left now it is false, and from right it is the same, plus left of index equal to high plus right of index equal to high. So I'll take the minimum of these two and I'll return the minimum. All right. So I think it should be clear. The E should be clear. And like for someone, I think it might not be clear if you don't know digit DP. So for that, I just recommend you that you should study digit DP. Okay. Like if you know that, then it is very useful. So you can watch from here this resources, or if you want a video, then on YouTube there are many videos about digit DP, so you can learn from that. So this is tight idea, right? Like this tight L and tight R, that idea comes from digit DP. Okay, it is not very easy to come up with that idea. All right. Okay, so let's do problem number D now. Sorry, F now. So you are given an array of integers a1 to an and two integers s and x. Count the number of subsegments of the array whose sum of elements equals s and whose maximum value equals x. Okay, so the problem is pretty simple to state that you have an array. You have an array of numbers, right? From a1, a2 to an. Okay, and you have been given some x and an integer x. I mean, some s and integer x. You have to count the number of subarrays L to R such that the sum the sum from L to R is equal to S, and the maximum element from L to R is equal to X, right? Okay. Video for digit DP. Uh, like I think there was one with Gaurish Baliga sir. So there is this video which you can watch for digit DP. All right. Okay. So yeah, we have to count the number of subsegments such that sum is S and max is X. All right. So what we can do here now, guys, one thing that I could ask you is, let's say my X was equal to 5. All right. And my array is given to be something like 1, 2, 3, 5, 7, 4, 3, 2, 5, 1, 3, or something like that. Or let's say 6 right here. Okay. So guys, here I want to count the number of subarrays L to R. Okay, such that the maximum equal to 5, and also sum equals to S. Sum equals to S, that is also there. But first, just focus on this thing. Okay, just focus on this thing. So what this is telling me is that I want the maximum value to be equal to 5. Okay, but in my array I have these numbers such as 7 and 6, right? If I have those in my subarray, then definitely my max cannot be equal to 5. That's for sure. Yes, guys. Like if I have these numbers in my array, then definitely my maximum cannot be equal to 5. Okay. So that's why I cannot take a subarray like this. So like I can simply split this array into different parts. I can just ignore the 7 and 6, and I can split my array into these different parts and just find out the answer inside each of them, right? The number of subarrays L2 are in each of them, and just add them up, add the answers up. Because it can't happen that I choose, like, I start from here, the subarray, and end at this. That is not possible because I have the 7 in the middle, right? So I can just break this array into different arrays. Okay, just find the answer for each of them and just do that, right? So do you guys get this? Okay, Raghav. All right. So yeah, do you guys get this? That if you can just divide like this your subarrays. Okay, just let me know, guys. Can you get this? That if you divide your array into these different subarrays, then you can just calculate the answer for them and add them up at the end, right? So guys, just say yes or no for this thing. What if we mark the indices for which the maximum element will be expected maximum using monotonic stack? I don't really get. I don't understand what you say. What you said. Okay, proceed. So yeah. So what I was saying is, you divide this into like this, right? So whatever subarrays you have now, okay. So all subarrays now, all subarrays now have a maximum value less than equal to 5. Okay, like whatever subarray you choose now, either from this array or from this array or from this array, its maximum value will be less than equal to 5, right? But actually we need the answer for at exactly 5. Like, we need the maximum value exactly 5. Okay, that's the problem. Like, see what you could just do here. Okay, so before that, i'll just uh, I'll just make you do one more question, which is a bit similar than this. That given an array A, given an array A, find the number of subarrays, number of subarrays L to R, such that the sum from AL up to AR is equal to S. This S is given to you and this array A is given to you, and find out the number of subarrays L to R such that this is equal to S. So do you all know how to solve this? Just tell me, guys, do you all know how to solve this problem? No. Okay, so first of all, we'll learn how to solve this problem. Find the subarrays whose sum is greater than equal to S minus subarrays whose sum greater than S. I mean, how will you find the sum? How will you find subarrays whose sum is greater than equal to S? That is the question now. But instead of that, I have a simpler method. I have a simple method that you can use. Okay, so you can see here that what is your sum from L to R, like this AL to AR. It is just prefix sum from R minus prefix sum from L minus 1, right? Like this is your entire thing, right? You can write subarray sum like this: prefix sum till r minus p of l minus 1. Okay. So you want this equal to s, right? Okay. So what you can simply do is, you can, like, if you have an array, you have an array, then just make its prefix sum. Just make its prefix sum. Okay. And now just iterate. Like, let's say you have this prefix sum array. Okay. You have this new prefix sum array. So now just iterate over this array. All right. Like, just make a pointer called r and just iterate it forward. Now just find out that for this r, how many l's are there such that p of r, pr minus p of l minus 1 is equal to s. So just find out that how many l's are there such that l is less than r, less than equal to r, or yeah, less than equal to r, such that p of l minus 1 satisfies this equation. So basically, since you know p of r and since you know s, you can simply see that p of l minus 1 equal to p of r minus s, right? So you want all the indices, like you want the number of indices for which the prefix sum is equal to this value, right? So for that, you can just give a map. You can just give a map of this frequency, that how many times this has occurred. Like, you can just make a map from int to int, right? Where m of I will store that how many times the sum I has occurred till now. Okay. Yeah. So I am telling you that all possible scenarios only. So using that, like, you can just iterate on the prefix sum array, and for a certain value of r, just find out that how many values are there for that p of l minus 1 is equal to p of r minus s, and just add it to your answer. So ans plus equals to map of pr minus s. All right. After doing this, you will just do map of pr plus plus, right? Rohit, I think around 1900, I guess. 1900. So yeah, do you guys get it? That's how you can find all the number of sub-arrays whose sum is equal to s. You can just iterate over this r and calculate all of the l's for which p of l, or p of r minus p of l minus 1 is equal to s, using a map, right? So I'll just show the code for this part. Okay. I have a function for this. So as you can see here, this function will return like this. So this function will return the number of sub-arrays which have the sum s. Okay. So if v dot is equal to 0, return 0. All right. So first I'll make the prefix sum array, and I'll make a map. Initially m of 0 plus plus and ans equal to 0. I'll iterate over the prefix sum array. So for int I equal to 1, I less than equal to 1, I plus plus. Ans plus equals to p of I minus s. M of p of I minus s. That is how many times it has occurred, right? And then I increment this prefix sum in the map. So this function will return the number of times, I mean the number of sub-arrays for which the sum is equal to s. Okay, fine. So how to find now we know how to find all sub-arrays. Like, how to find the number of sub-arrays. How to find the number of subarrays with sum equal to s. Okay, this is done. Now let's say I tell you that how to find. Now one more question. Okay, this was question 1. This is question 2. How to find the number of subarrays having sum equals to s and maximum value is less than equal to x. If you have this question right here, then what will you do? Like, let's say I have given you an array. I have given you an array a1, a2, a3 up to an, and you want that the sum is equal to s and maximum value in that subarray is less than equal to x, right? So again, what will you do? You will simply do the same thing as in this one. Like here, what we did, that all the elements greater than 5 we just ignored, and we just broke this vector into multiple vectors and just found the answer for them. So here also, what we can do is we can just find out all the elements which are greater than x. Greater than x, we can find out all the elements. So like, let's say a2 is there, a4 is there, an is there. So I will just ignore them because I cannot have them in my subarray, right? And then the remaining portion, like this subarray, this subarray, I mean, now they are new arrays for me, and I can simply find out all of the, like, for this array I can find out the number of subarrays with sum equal to s. Then for this subarray I can find out the subarrays with sum equal to s, and then I can just add them up, right? Because it is not possible that I take L here and R here, because in this case A2 would come in my subarray. So that's my point, that you can just, if you want to find out the number of subarrays with maximum value less than equal to x, then all those indices where the value is greater than x, just ignore them. Okay, and the remaining vectors between those, just find the answer for them. And definitely whatever subarray you have there, all subarrays will have max element less than equal to x, right? Less than equal to x. So what you can simply do is just count all of them, and that's your answer. So do you guys get this part? What if we have another prefix sum for the max value to know if there are any max in the range? It will be complicated. You can't really do that. Just try thinking about it. You will not be able to do it. Anyways, so this problem, that how to find the number of subarrays such that sum is equal to x and max is less than equal to x. That is just, you can just break the array at all the points where the element is greater than x and find the answer for the vectors in the middle, right? Okay, and for all of the subarrays, the max is less than equal to x, so it is correct. Okay, so now that you know that how to find the number of subarrays for which sum is equal to x and max is less than equal to x, can you use this to find the answer to sum equal to s, um, sum equal to s and max is equal to x? Can you find this out? Like, if you know the answer, that how to calculate the number of subarrays whose sum is s and max is less than equal to x, then can you figure out how to use this answer and find out the subarrays whose sum is s and max is equal to x? So actually, what you can simply do is find out the answer for sum equals to s and max equal to x. Okay, and just find out the answer for sorry, max not equal, just find out sum equal to s and max less than equal to x. Just find out these many arrays, then also find out the answer for sum equals to s and max less than equal to x minus 1. Okay, so basically this will contain all of the arrays whose max is up to x, right? And this will contain all the arrays whose max is up to x minus 1. So if you subtract this, then this will contain sum equal to s and max is equal to x. If you at equal to x, then you would have to, okay, then what would you do? Repeat. Okay, so what I want to say, sir, Aditya, did you get this part? That how do you solve this? How to find number of subarrays such that sum equal to x and max is less than equal to x? Aditya, do you get this part? That how do you find the number of subarrays whose sum is equal to s and max is less than equal to x? Aditya? Okay. So since Aditya is not responding, I am assuming that he knows. Okay. Like, let's assume that he knows that how to find the number of subarrays with sum equal to s and max less than equal to x. Then what you can do is, let's say you want to find the number of subarrays whose sum is equal to s and max is equal to x. Then just find out the number of subarrays whose sum is whose sum is s and max value is less than equal to x. Okay, so this will contain all the subarrays whose max value is up to x, right? And also find out the subarrays whose sum is s and max value is less than equal to x minus 1. So this will contain all subarrays whose max value is less than equal to x minus 1. So if you subtract this, then what will be left? What is left is sum equal to x and max also equal to s. Max also equal to x. Okay, so Raghav, do you understand this? That's how you can simply do it. Okay. Uh, Cricket Darshan, whatever your name is, I did not look at the problem G because I was stuck at the problem F for a very long time because I was trying out a very different approach. So I did not read the problem G. So I did not think about it. So I can't really give hints. So if you want hint, then maybe you can look at the editorial. Like maybe in the editorial they have given hints or something, I guess. Uh, no, there's no hint. Then you need to do. Repeat that part only. Okay. So what we want to solve here is that find the number of subarrays with maximum value less than equal to x and sum equal to s. Okay. So let us just take some values. Okay. Let's say I have 1, 2, 3, 1, 4, 5, 1, 2, 4, and 2, 3. Okay. So let's say x is equal to 3. All right. So Aditya, what I am saying is that you can never have this 4 or this 5 or this 4 in your subarray, right? You can never have them in your subarray. So if you take the starting point as this one, let's say, then ending point has to be before this 4, right? It cannot be after this, like it cannot be after this 4 and 5, right? So what you can simply do is that you can delete this, like just ignore these elements, and just decompose the vector into these different vectors. So these three vectors you have, which have all the elements which are less than or equal to x, right? And in these vectors you can find out that what is the number of subarrays with sum equals to s, right? So if you find out the answer for this vector, for this vector, for this vector, you will be sure that all those subarrays will have max less than equal to x, because all the elements themselves are less than equal to x in these in these arrays, right? And simply you can just add all their answers. Okay. And why you can add them? Because it is not allowed to take L here and R here. Like you cannot take one boundary as here and one as here, because in that case these two elements would be there in your subarray, and you don't want that. So that's how you can count the number of subarrays with a maximum element less than equal to x and sum equal to s. Okay, Aditya. Focus is asking monotony starts for breaking at x. Like I don't really understand that after you break at x, then what you will do, and what is monotonic? Like how does this monotonic stack come here? How I mastered digit DP? I just did. I think some problems. Not even that many problems. Like on CSCS, we have a problem on digit DP, counting numbers. So this problem is actually um, your digit DP problem. So you can calculate, like you can try it out. And yeah, on Usago guide as well, you have digit DP. So on that, I think they must have given some problems which you can solve. So just try to solve these problems. All right. Less than equal to x minus less than x. Yes. So you'll get equal to x. Store all the index corresponding to a prefix sum and store the last position of x. Then minus has the number of position. Store all the index corresponding to a prefix sum and store the last position of x. Then minus has the number of position of for less than x and add them to the answer. If any number greater than x, then reset map and sum. Okay, I think. So yeah, this is also nice idea. Yeah, this is correct. I mean, the implementation is very tough for this thing, but it is correct. I was trying to do like this only. That's why I got all these wrong answers, and that's why I could not try G as well. Like I was trying like this only. Like I was trying two pointers, but it did not work out. Anyways, on G, I don't know. If we want maximum equal to 5, we'll expand on both sides of each 5, and this can be done monotonic stack. Man, I don't think this will work. You can just try by yourself, and you'll understand that where it fails. Okay. Problem C. We swap only if bi is greater than ai. So by transitivity, um, AI is greater than AI minus 1 and BI is greater than AI. So new AI is greater than AI minus 1. But what about the new BI? Is the new BI greater than B of I minus 1? Yeah, F was easy. Like, actually, it's just about striking. If that strikes you, the method, then it is easy. Otherwise, it is pretty hard. Yeah, that is fine. But what he's saying is that, okay, first we sorted it, right? Or wait, what we did? Yeah, so first we sorted the arrays. So AI minus 1 is less than AI, and B of I minus 1 is less than BI. Okay. So then he's saying that um, we will swap them, right? So now it will become AI minus 1 and BI, and BI minus 1 and AI, right? And we know that this AI is greater than BI, right? So now, what can you say about this BI minus 1 and AI? Since we knew that BI minus 1 is less than BI and BI is less than AI, we can say that BI minus 1 is less than AI. This is right. Okay. But how do you compare AI minus 1 and BI? Not really, Plomo. IIT ho gaya. Congrats. Like, which IIT? Can you repeat the part of counting sever after breaking? So basically, you want me to explain the first one as well. Like, you want me to explain this, that how to find the number of subarrays with sum equal to s. Right, Aditya? Great, Tanish. Okay, so for that, you can simply see that, like, subarray sum is what? Subarray sum means AL up to AR, right? AL plus A of L plus 1 up to AR. Okay, so you can write this as the prefix sum of R minus prefix sum of L minus 1, right? So basically, if you have a prefix array, like, first make the prefix sum array, all right, and then just iterate over this R, like, just make a pointer for R and move from left to right. Okay, and for every R, find out that how many L's are there, such that this P of L minus 1, like this P of R minus PL minus 1 equals to S. That is, P of L minus 1 should be equal to P of R minus S. So just find that out, that how many L's are there, such that PL minus 1 equal to PR minus S. Okay, and you can just keep that in map, like whatever indices you have already passed, just keep their prefix sum in a map. All right, and then you can just add it to your answer. Okay, Aditya. All right, so I'll just show the entire code now. Okay, so we have here In solve function, I have nsx, c in nsx, vector vn, and I'll see in the vector v. Then I have this ve vector, which I am just using temporarily. Like what I'm doing is, um, I'm iterating over this entire array. Now, if v of I is greater than x, that means, like, in this loop I'm calculating less than equal to x. Okay, so if v of I is greater than x, then I'll break it here. So I'll just add the answer of this v vector currently to my an variable, and then I'll clear the v vector. Otherwise, I'll push back v of I into my v vector. And finally, also, I'll again add the answer of v vector to my answer. So essentially, what I'm doing is, whenever I'm getting a number greater than x, I'm just clearing my vector, and otherwise, I'm just pushing back the element into my vector, right? So this is I'm doing, like, I'm adding all the answers into my an. Now I am subtracting for the answers for vi less than x, like max less than x. So if vi is greater than equal to x, I will subtract the answer for this vector ve, and v dot clear. Otherwise, push back vi, right? And finally, also, an minus equals ans of v comma s, and then just print an. And this ans function just returns the number of subarrays with sum equals to s, using the same map concept, like ans plus equals to m of p of r minus s and m of p of r plus plus, right? Anyways, so I hope you all understood this entire thing. Okay. All right. So I'll take your leave for now. So it is very late now. So I'll take your leave, and I'll see you guys later. Okay. Bye bye, everyone.